Hello and welcome back to Advent of Code 2024, day 22, which is about to open in about 40 seconds. Hello, DJ. Here, decided to get started on time today. Right, we just wait. And go. Monkey market. As you're all teleported into the jungle, a monkey it's the monkey from 2022 steals the historian's device. You'll need to get it back while the historians are looking for the chief. The monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. Your only option is to buy bananas on the monkey exchange market. You aren't sure how the monkey exchange market works, but one of the historians senses trouble and comes over to help. Apparently they've been studying these monkeys for a while and have deciphered their secrets. Today the market is full of monkeys buying good hiding spots. Fortunately, because of the time you recently spent in this jungle, you know lots of good hiding spots you can sell. If you can sell enough hiding spots, you should be able to get enough bananas to buy the device back. On the market, the buyers seem to use random prices, but their prices are actually only pseudo-random. If you know the secret of how they pick their prices, you can wait for the perfect time to sell. The part about secrets is literal, the historian explains. Each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. You multiply by 64. Then mix this result into the secret number. Finally prune the secret number. Right, don't know what those mean. Calculate the result of dividing the secret number by 32. Mix into the secret number, prune. Multiply by 2048. Mix, prune. So it looks like mix and prune always come together, so it could be like one method, I suppose. Each step of the above process involves mixing and pruning. To mix a value into the secret number, calculate the bitwise XOR of the given value and the secret number. Okay, then the secret number becomes the result of that operation. To prune, calculate the value of the secret number modulo that. Alright. Okay, that's easy. You just do Python XOR, it's the carry operator. After this process completes, the buyer is left with the next secret number in the sequence, so the buyer can repeat this process as many times as necessary to produce more secret numbers. So if a buyer had a secret number of 123, the next 10 would be this. Each buyer uses their own secret number when choosing their price, so it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number of each buyer. For example, 110, 100, 2024. This list describes the initial secret number of 4 different secret hiding spot buyers on the monkey exchange market. If you can simulate their secret numbers from each buyer, you'll be able to predict all of their future prices. In a single day, buyers each have time to generate 2,000 new secret numbers. In this example, for each buyer, their initial secret number and the 2,000th new secret number they would generate are that. Adding up the 2,000th new secret number for each buyer produces that. For each buyer, simulate the... Okay. Okay. I have a bit of a cough today. So... these are the buyers. Okay. So it's 2,100 roughly. So buyers equals this. And buyers dot and int 9. So we want to define evolve, basically. Evolve of a secret number. So let's read this again. Multiply by 64. So it's num times 64 XOR num result equals, so that, well, it's not the final result, that's the first step. Oh, prune the secret number. So it's going to be mod that. So that's stage 1. Stage 2 is going to be similar. It's going to be oops. But it's going to be num divided by 32. Do I need to put brackets here? I guess we'll test it and see. Also, don't stop putting spaces. Alright, and then... finally, we multiply by 2048. Return result. So for buyer in buyers, we want to basically, for in range 2,200, check. 2,000. Oh, okay, it's quite a lot. But it's arithmetic operation, so 2,000 by 2,000 should be fine. Secret. These should really be secrets. And then what? Just add it up. Result. Is that it? And we've got nothing. Oh, because it's taking forever. Okay, fine. Result equals... I don't see anything wrong with this. It's just 2,000 by 2,000, so I guess several million. It could take a while, but it shouldn't be too bad. Exceeds the limit for integer string conversion. What? Never seen that before. We got too big an integer. Alright, I think this order of operations is not correct. Let's put the brackets in. I never know what the order of operations are. I think we're not modding correctly. There we go. Nope. 2,000th new secret number they would generate. Am I... Okay. This is wrong. Hang on. So this is the problem with result equals... Let's just do this. Result equals num. Stop using num from now on. Look, why have I got nums in there? There we go. There we go. Should be better. Correct. Hot 2. Of course, the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyer offers are just the ones digit of each of their secret numbers. So if a buyer starts with a secret number of 1, 2, 3, that buyer's first 10 prices would be... Okay, so it's mod 10. This price is the number of bananas that buyer is offering in exchange for your information about a new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little, but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Unfortunately, the monkey only knows how to decide when to sell by looking at the changes in price. Specifically, the monkey will only look for a specific sequence of 4 consecutive changes in price, then immediately sell when it sees that sequence. So if a buyer starts with a secret number of 1, 2, 3, that buyer's first 10 secret numbers, blah, blah, blah. Note that the first price has no associated change because there was no previous price to compare it with. In this short example, within just these first few prices, the highest price will be 6. So it'll be nice to give the monkey instructions that would make it sell it at that time. The first 6 occurs after only 2 changes. There's no way to instruct the monkey to sell them. But the second 6 occurs after the change. Okay, so if you gave the monkey that sequence of changes, it would wait until the first time it sees that sequence and then immediately sell your hiding spot information at the current price, winning you 6 bananas. First 6. Why can't we do the first 6? You have to give them 4 consecutive changes. Okay. Each buyer only wants to buy 1 hiding spot. So after the hiding spot is sold, the monkey will move on to the next buyer. If the monkey never hears that sequence of price changes from a buyer, the monkey will never sell, and will instead just move on to the next buyer. Worse, you can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. Oh god, okay. Fine. You're going to need as many bananas as possible, so you'll need to determine which sequence of 4 price changes will cause the monkey to get you the most bananas overall. Each buyer is going to generate 2,000 secret numbers after them, blah blah. So for each buyer, you'll have 2,000 price changes in which your sequence can occur. Alright. So if we say -2, 1, -1, 3. Alright, I sort of get it. What is the most bananas you can get? We don't have an inventory. We're selling this one secret for this many bananas. So it's basically gaining the bananas. Alright. Interesting. So for now, I guess we want to store all this. Prices equals a list of lists, I suppose. Prices. So just take that out. So we want prices -1 and num. Call this price lists. Sum of price lists $2,000 for P 2000 for P in price lists. $2,000-ish. That's right, isn't it? We put num in. What? P. List index out of range. If we put 2000 in, wouldn't that have index 2000 at the end? What if I did -1? But I shouldn't need to. 1772, is that the same answer? 040. Yeah. Why is it not 2000? Okay, 1999. That's out of range. What's going on? No, somewhere in my... Price list is a list. Get rid of that. The secret in secrets. Num is a secret process. Num range. Num equals evolve. Oops. Okay, I get it. So it was just containing the last one. Okay. That was just an indentation problem. So we've got all the prices now. So this, we never care about this anymore. Like, this is now stored. All the prices are stored in price lists. All right, now what? We're trying to find the sequence of diffs. Which would maximize interesting. I think I see how we do this. So excuse me. We want some hash sets. Or for each price list, we want a difference table. This is going to map a sequence 4 integers to the amount of bananas we'll get from that table. But wait. Yeah. Well, this cuts out 2000, 2000. Yeah, this should work. All right, so for key in price lists, we stick a table in there. All right, and we're going to say, given this sequence, what price do I get? And if something is not in a table, we want to return 0, so maybe it should be a default dict. Okay. Or just, let's just build this up for now. D equals that. Okay. And we can append it to begin with, it doesn't matter. Alright, D equals that. Alright, so this is going to... And now... So given one of these, let's have a look. Print price list 0. Okay. So this is what one of them looks like. So we want to start from hang on, so they said the first one counts as having a difference of 0, right? It said something about that. No. The first price is... Ah, no. We're storing the final the units digit, aren't we? Okay, price lists. Okay, price lists, and the stores separately. So the score for part 1 is the 2000 secret number. Okay, so part 1 result equals 0. All right. So part 1 result plus equal none. All right, it's because we want we don't want this. Well, this is just going to be part 1 result. We only store the num %10. We only store the first digits. Okay, let's try that again. The final digits. Okay. Okay, good. Yeah, that makes more sense. Okay. And now... for I in range... So we start from... So only, like, the first 5. Okay, so after the first one, the next 4 have differences. The first one doesn't count. Does it? Hang on. What they said something about this. No, it doesn't count. Alright, so we have to start from... So the earliest we can see something is 4. So 4 length of P. So the diff is gonna be it's going to be I minus, yeah, so it will, or plus I, so it'll be I minus 1, I minus 2, I minus 3. Okay, I minus 3. So it'll be P I minus 3 minus P I minus 4. And then basically minus 2 minus 3 minus 1 minus 2, and then I minus 1. So that's the diffs. Alright, so this is the diff. If it's already in the dictionary, that means we've already seen it before and this doesn't count. Alright, because the monkey only goes with the first one it sees. So if diff in D, skip this. Otherwise, we've got something. So, P diff equals, and the price is going to be I, right? P I, the one we're looking at. 0, 1, 2, 3, 4. So let me check. Immediately sells when it sees that sequence. Yeah. So it'll be whatever the one we're looking at is. That's the price. Alright, so if we do this table, I think we basically have something. So we can now say, let's just see what this looks like now. Oh, not this. See what the first table looks like. What have I done here? D diff. Okay. So we're saying that maps to 2, that maps to 3, and so on. Alright, 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 alright. Okay. Now, first we need to know all possible diff vectors. And we don't need to try all -10 to -9 to +9. We can just take the keys of all the diff tables. So diff candidates equals is there like a union, like a which does like union is a, can we do like a map reduce type thing? I think, how do you do this? It's like Python map reduce set union. You want to use reduce, right? To oh, you don't want to use reduce in this way because it builds intermediate. Ah, okay. You want to do it this way. Hang on. So set union. You want to do set dot union, and then a list of parameters. So it's going to be d dot keys for d in diff tables. Or set of d dot keys for d in diff tables. Is that right? Oh, you can't use a generator. Can you do that? Alright. So, stop printing things. Print diff tables. Okay, we know that's fine. Is this... I think that's right. So let's just try it. Print diff candidates length of candidates. Alright, so it should be something like 1 million or something, I don't know. No, not 1 million. It'll be like... Okay, that many. There'll be duplicates as well. We've got 40,000. Alright. Now, the idea is for each one of those 40,000, we have to spend 1,000 operations to... Maybe there's a better way to do this. We can say, Alright, I think we don't need to store this as a table. Instead, we just want sets. And whenever we see a diff, so the final thing we want is the sum of prices, right? We get from this diff. So we might as well just say, okay, so this is diff sets because we want to. Okay, we don't need to store one for each one. Here, this is what we do. Diff set. That's the set of all differences in existence, right? And actually, we don't even need that. Okay, I think diff table is what we need. And this is going to say for each possible diff, every time we see it, the first time we see it in a price list, we're going to add the price to this value. So it will start off at 0. If we see it here in one of these price lists, then we'll add 7, say 7 bananas to the value here. And if we see it again in another one, we'll add 3 bananas and so on. That way we don't have to use quadratic time to then research all the tables later on. So that should work. So now the only catch is, yeah, this is going to be a default dict on an int. We have to make sure the first time we see something is the first time we use that. So d equals set if diff indeed continue. All right, so then we do diff table diff plus equal p I. So we add the price we get for that, and then d dot add diff. Add this so that we never use that diff again for this one p. Okay. So the idea is now we've got a diff table, a full map of all possible diffs and the prices we would get across all sellers. So now, is it literally just print max of diff table dot values? Is that it? We want the max, right? $1,998 sounds low. Well, no, it sounds okay. That sounds about right. Correct. Oh, thanks for the raid. Who was that? Vu? Well, sorry, I might have missed it when you raided. I don't know how long ago that was. Were you doing this as well? So it looks like I've just finished. So how fast did I do this? Because I started on time. About 40 minutes. I mean, obviously it's not going to be a top 100, but I'm just curious how... Okay, it was within like 12 minutes. Yeah, I'm not getting that. 46 seconds to do both? Really? Yeah, it's ridiculous. Oh, there's a lot of ChatGPT going on here. Come on, there was a lot of bulky stuff that you kind of had to read through, so... Some bits you had to read through. I think you could miss out... some paragraphs which didn't have keywords in them. Alright then. Leaderboards, private leaderboard. Only one person's done it so far. Yeah, so that second part is actually less complicated than I thought it'd be. It's really just keeping good hash tables. It's easy to fall into the trap of doing some for loop where you're... Which was kind of what I was setting it up for. So I would store on a per buyer basis a table of diffs to prices, and then I would go through the full list of diffs, and for each one, go through all those tables and add the price for that diff. But I mean, if we know in the end we're just going to be adding them, we might as well just add them to begin with. So yeah. And part 1 was completely different to part 2. Part 1 you just had to do those mathematical operations. My leaderboard. Nobody. I'm the first one on my own leaderboard. That's a first. Well, to be fair, a lot of people start much later. I started on time this time. I don't normally do that. I probably will for Christmas Day, though. Alright. That was a good problem. Alright, I guess there must be lots of people still doing it then. I don't think I'll raid. I don't really have many viewers right now. In that case, I might switch to some satisfactory. Alright, maybe. I might need to sort some other stuff out first. Alright, that's it. That's day 22. We've got 3 days left. The final day will only be a part 1, which may mean it's shorter, but you never know. It can be a really nasty part 1. And as long as I keep up with... Did I finish 21? Yeah, I did. Actually, not long after you left, I sort of realized how to express it as a recursive memorization method. So, and that worked. I think the key insight was that every robot, after it's pressed a button, it returns its hand to A. So if you realize that, then you realize telling a robot to move from somewhere to somewhere when you start, all the robots after him are all going to be pointing to A, and when he finishes, all the robots after him are going to be pointing to A. So once you realize that, then you can break this down into a recursive function, because you don't have to worry about where all the robots are, because they're all going to be pointing to A, and then that means each robot is only dependent on what the next robot after him is doing. It's a recursive method. I can't easily explain it, but yeah, that was the gist of it, and doing that just worked. So no heuristics, no. So my original idea was I thought a heuristic approach would work, and it didn't. And it turns out the shortest path is not obvious at all, because you want to avoid... Whenever they move their finger left, that's a more expensive operation than moving right, because the left button is further away on the directional pad. But you can't avoid moving left. You have to move left. The point is, whenever you need to move left, you want to do all your left presses consecutively. That's the reason why the shortest path is not obvious, basically. So you need to find ways to group all your lefts together, not go left, down, left. If you do a snake-like pattern, that's worse than going down, left, left. So I think there is a heuristic approach where you prefer lefts and then middles and then rights. That's probably the fastest solution, but my solution was the more complete one, I guess. Didn't use any heuristics. Yeah, 21 was 21 I think was the hardest problem so far, and I think a lot of people agree. A lot of people have given up at 21. I mean, we can actually maybe see that in the board. Okay, some people have caught up with 21. Yeah, okay, so on my private leaderboard, 21 is clearly a problem point. And if we look at the stats, Amaro slacking. Well, Amaro and myself were the only ones who beat 21 for like a long time. And then the others caught up. So 21 was definitely hard. 20. I'm curious as to what Amaro did, though. I'll have to ask him, because I don't know if he used the same solution that I did, or whether he figured out the heuristic approach. Because the heuristic approach is just like, I could have had the whole problem done in the first hour if I had found the right order of keys to follow, which is prioritize the lefts, then the middles, then the rights. It's not obvious why that works, though. You'd have to use some sort of mathematical proof. I don't think you could easily prove it. mathematically, but if you had a gut feeling that that's optimal and just went with it, you would get the answer pretty quickly. Um, yeah, 21. Well, there's a not terrible ratio of gold stars to silver, so but there's very low solves overall for 21. But so like only 2/3 have solved it. I guess that is the six. Six seems to also be a really bad ratio. What was that again? It was the one with a guard. I didn't think that was that bad. Apparently, a lot of people didn't do part two for six. It surprises me. I think there were worse ones, like the farming one. The farming one called people out, so I don't know. I didn't think this was that bad. It's just like you do your breadth first search or whatever in a for loop, and that just worked. It just took a while. All right. Okay then. Well, see you tomorrow then for the third last day, I guess. Bye bye.